Hello everyone, this is a live stream, Supply Chain Analytics, Week 2, Lecture 2 on Inventory. Usually this is a Zoom, but I'm having a live stream tonight to go over the homework. I posted a announcement in Canvas, and even if you're unable to be here tonight, this will be rendered as a video and posted on a link on Canvas for the video. Now the reason I'm doing this is because when I went through the lecture this week, I realized, and I think I mentioned this, I got a feeling this is way too much information, covering too much material, too technical for 1 week. So therefore, tonight I thought I would just go over the homework on how to get started. But then also, since then, I've thought more about it, and I'm going to be changing some of the due dates. Give us more time to work on this lecture, on this homework assignment, because there's a lot going on here. There's a lot of moving parts. And rather than rush it through, I'd much rather people learn it slowly. And so some of the other homework assignments coming later, it will not be like this. You can do it within a week easy. Lecture on Monday, and then maybe even a Zoom or live stream again. But usually within a week, it's perfectly fine. It's just you learn it and you got it. But this material, I began to realize this is a lot of material for a short amount of time, and but it's important material. And so I'll be making some announcements. So watch. You'll probably, I think I've decided. I haven't decided on the details, but I think what I will do is not have this due this weekend on Sunday. It'll be due later. Now, I consider this a lecture, and so therefore I do have a chat room, and you can ask questions, and I will answer them if I can. Otherwise, I'll just go right through this material. Now, I'm not going to work the problems all the way through. What I'm going to be doing is showing you where to find the material, how to set it up, in a couple of cases, how to work part of the problem and bring it to a point and then stop and say, you finished the rest, that type of thing. And so this is kind of like working it with you, but not for you. Okay, let's bring up the syllabus to see where we are. We can see here, this is week 2, and even though homework 1 is due on August 30th this Sunday, and no late assignments accepted, I'm going to change the due date on this to later, and I haven't decided exactly when or how. But the other homework assignments too has some quantitative, but then relationships, information strategy, that 3, 4, and 5, and actually 6 through 9, those can be done well within a week, no problem. Just this homework assignment, I think, is the only one that I have a problem with, that I personally have a problem with. Too much information. I want you to learn this stuff and be familiar with it, and you can't get it in 1 week. So that's what I'm going to be doing. Okay, let's reduce this, or let's minimize this, and let's bring up Canvas. So in Canvas, course material, coming down here, here's week 2. Here's the Zoom session, live stream. And this is the homework. So this is what I'll be going through. I'm going to go through this homework step by step, and not, as I say, not work it, but show you how to find the answers. Okay, so let's download this down here and open this up. I've already opened it up, so let me open one that's already open. There we go. So I know the place of it. Full screen this. Okay, now as I go through here, actually let's not full screen this. Let's bring this down. Let's minimize this. Okay, as I go through here, let me bring up the lecture and show you where in the lecture the material is. Now, if you notice, I have this takeaways here, and I've been thinking a lot about this course, and these takeaways I think will be expanded, and instead of focusing on the mechanics, I'll be focusing on the takeaways more, and I want to make sure I do that for the rest of this course. And so you're taking away things to use them as a manager, because this is not a liberal arts and science course. This is a business course, and so we'll be, and it's an analytics course, so it's a business how to use analytics, okay? And we will be working analytics, but it's going to be a little bit different balance, okay? And also, if you remember, I gave this model, which is a very good model to keep in mind as far as upstream and downstream for a stage. It's like this is one stage here. And then I have these definitions. So these definitions I'll be using in some of the questions in the homework. Okay. Then I get into the overview. Okay, now let's go to the homework real quick. Let me just move this out of the way. And notice what I did here. Here's these simple takeaways. Here's, well, takeaway topics. But notice the main topics. Now these represent the equations. These are the equations that we'll be using. And so let me just point out here before we get into more depth on this thing. Make this bigger so you can see it. Or see it easier. Okay, the idea here is that these first 7, there's equations. And so for me, what's important here, I think in this course, as I looked at all my background's analytics, my background is very quantitative, and so when I think of these things that I can see pictures behind them. But then for business, I think it's better to look at the applications and then have the mathematics and quantitative supplement the applications and takeaways. So I'll be doing that the rest of this course, but I'll try to do that a little bit today. Okay, and then the appendix, you'll have the analytics for those of you who have a engineering background or a math background or any type of quantitative background, economics background. Okay, so these equations. Now these last 3, this is much more practical. The risk pooling, echelon, ABC inventory classification, those are very practical types of techniques that you will and can use, and everybody does use them. And so I do want to address those in detail. And a lot of these first 7 is just the concepts, definitions, relationships, which are important. Down here, these are embedded in here. This is how you use it. Okay, let's go through some of these. Okay, notice this first one here, primary type supply chain. And this first one is all about, 5 through 8. Constant demand, constant demand, constant demand, constant demand. So these, for constant demand, we're looking at relationships. You know, the lot size, demand, constant demand rate, inventory period, lead time, ROP, EOQ, etc. Okay, and so if you come back to the lecture then. Pull up the lecture. There we go. A lot of that is going to come right from this first page, page 2 in the lecture. I just pull it right off of here, mainly just to kind of review and say, identify and remember what we covered. And so that's what this first question is. And the second question is the same, except it's stochastic demand, stochastic demand, stochastic demand, stochastic demand. And in stochastic demand, there's where I'm looking at these relationships here. So like here's the lot size, here's the ROP, and we'll talk about this relationship quite a bit. And here's the base stock level for periodic review systems, and then the single period. Okay. Okay, and those are the first 2 questions. That's where you find them, and most of that is just relating it. It's just matching them up. Oh, this is the. So what I did a lot of times, I took all correct statements and I switched a couple, you know, just to say, oh, this goes with this and this goes with this. A lot of times I just did that. Okay. Now we get into quantitative stuff, and like I said before, I have a version A and version B. Version A is analytics. Version B is international business, or the managerial part, and I consider this qualitative. I consider this quantitative. However, I want to emphasize that to really understand the quantitative and use it correctly, you have to understand the qualitative and use it correctly. To understand the qualitative, you have to appreciate the quantitative. So they both go hand in hand. And so the version A focuses on the I guess you could say the deductive relationships, and version B is the inductive relationships. Sometimes it's it's inductive, but it's closer to deductive. And so this is more terminology and relationships, and this is more concepts. Okay. Okay, so this first one is constant demand. Okay, so for constant demand, if you notice this, I give you the inventory policy, lead time, safety stock. Okay, so actually let's come back up here. Let's do it this way. Let's take these first four, bring them down here. 1, 2, 3, and put them right here. Bingo. Okay, now notice this first one for an inventory. Now when you have two numbers, that's going to be ROPQ. When you have a time in a number, that's TQ. So you know that this is a continuous review, and you know this is periodic review. See, I don't say it here. I just say the inventory policy of that. Well, you know it's continuous review. It's not periodic. It's continuous. And the lead time of this safety stock. So lead time safety stock, well, that's going to be ROP. See the lead time safety stock, 86 is ROP. The demand is 3040. Is that true? So you have everything you need. So the question is, if that's the ROP and that's the lead time and safety stock, are all the numbers right? Or are they not right? Do they not match up? So it's just a matching thing, like a true-false kind of thing. And likewise for this one is the inventory period T, which is this T right here. A lot size 304, and that's this one. And the annual order frequency. Okay, well, if the inventory period is 1.2 months, remember, I could say also this, Q equals D over F, okay, because T equals 1 over F. 1 over 1.2 months is the order frequency in months, but if you transform the months to years, and 1 over that is the annual order frequency, okay, so if the inventory plot is 1.2 months, what part of a year is 1.2 months? Well, there's 12 months in a year, right? And so you divide 1.2 months by 12. Okay, and actually you can kind of see what's happening there. 1.2 divided by 12 is 0.1. You can do it in your head. 1 over 0.1 is 10. Is that 20? No. So I've answered that one for you. Sorry. I want you to do them yourself, but it's hard not to. It's right there in front of you. Okay. Anyway, and then for an optimal inventory policy, optimal refers to EOQ. Bingo. So you know what EOQ is. So it's 173. Well, it's 173 is EOQ. ROP is 86. The inventory period is approximately 5.2 weeks. Okay, so if you're given Q, and if you're given the demand in the inventory period, so do all these numbers pan out? Essentially, okay. And demand, you always have demand. Demand's the same for all of them. So do they really work together? And then finally the lead time and safety stock. And here's the ordering cost, carrying cost. And so I'm giving ordering cost, carrying cost. Demand's given, so you know EOQ. I'm giving the lead time and safety stock, so you know ROP. So essentially you know the inventory policy. I don't give it to you, but you can calculate it. But I don't ask for that. I say, oh, the total annual inventory cost for a minimum cost inventory policy is that. So there you calculate the total inventory cost. Okay. Now the total inventory cost equals the total ordering cost plus the total carrying cost. Okay. Now that equals the order frequency times the unit ordering cost. So the unit ordering cost is right here, $128 per order. What's frequency? Well, you can calculate EOQ, right? You can calculate your inventory period. If you know what Q is, you can calculate your inventory period with the demand. And so you just algebra. You just start figuring this stuff out. But the ordering cost is Q. Let me say EOQ. EOQ over 2 plus safety stock times the carrying cost. Okay, but in EOQ and safety stock, so if I want the annual inventory, this carrying cost must be the carrying cost per item per year, not quarter. Well, if it costs $6.50 a quarter, 4 times that is how much it is per year. Or 4 times 6 is 24, plus 2 more is 26. But the point is, that's what the carrying cost per year to get the annual cost. Okay, so that's what I'm asking for, and that's how you calculate it. And then down here, notice it's the same questions, but I don't talk about the numerical aspects of these things. I talked about the relationship. If the safety stock increases, the reorder point decreases. If that increases, then what happens to that? That's all I'm saying. And so it's just getting used to the relationships. And the more you use this, these kind of relationships become very natural. But I'm assuming nobody has done this, and this is new. So what I'm really looking at then is let's go through this to make sure everyone is familiar with it. Okay, I have some questions here. Live stream on Thursday instead of Zoom. Well, I am today, and I might next week, but later I'll be doing Zoom. Now, if you want to do a Zoom tonight and you do have some questions, when I'm done with this live stream, I'll open the Zoom up, and you can ask questions. So we can have a conversation right after this this live stream. And that might be good. That way I can wait for YouTube to render this as a video before I post the link. Because YouTube takes a while to make it a video, because they do all kinds of rendering when they render this thing. For statement 4, lead time is 0.3 months. So does that mean if we wanted to convert it to years, 0.3 over 12? Well, think about it. If the lead time is 0.3 months, let's say the lead time is 1 month. How much is 1 month in units of a year? It's 1/12 of a year. So it's less, right? So, yeah, you divide by 12. So that's the right idea. Okay. But on the other hand, Sandeep, on the other hand, if you wanted to take the demand per years and go to a month, you'd divide by 12. Because if it's 33,040 a year, it's 1/12 of that for a month. And by the way, now's a good time now's a very good time to mention, go to my website. Well, let me go to my website, watch me. Go to Operations Management. I probably should pull this over to Supply Chain. And under the introduction, I have time conversions, this video 2. I would watch this video too, because what I do here...
Welcome to the...
Oh, man. What I do here, I have the sound up high, is time conversions. And it goes back and forth between the time of, you can see here, time of, I talk about how you, in detail, demand and lead time and safety stock and all, I mean, not safety stock, inventory period. I just go back and forth between these things, and that would be a good video to watch. The time conversions under introduction, video 2, under the operations management. Okay, and that'll, if you're interested, there's a lot going on here. Okay, well, that's 3. 4. Then I go to stochastic demand, normally distributed weekly demand data. Then I go to stochastic, and I ask for the reorder point, lot size, base stock level, safety stock. Okay. If you have a lead time, inventory period, and stock out level. Okay, now to do this, let's bring this down a little bit. To do this, you're going to have to calculate the mean and the variance and the Z value for the stock out level. Tell you what, let's do. Let's come back up here. Let's take the stochastic demand. Here we go. Control C and bring this down. And under question 4, let's put it right here. Bingo. And there's the equations we'll be using for this up here and for this down here. Okay. So, but in order to do this, you're going to need the mean. There's the mean. You're going to need the standard deviation, that's sigma. You're going to need the Z value of your stock out level of 10%. So let me show you how to get those. Those 3 things. You need those to plug and crank. Okay. And notice lot size. See, reorder point is going to be that one right there. Lot size is that one right there. The base stock level is this one right here. The safety stock is approximately this. It's going to be, well, the safety stock is that right there. Okay. I do the single period later. But to do this, you have the lead time LT, you have the inventory period T, you have the stock out level, you need Z. You need mu, Z, and sigma, and let me show you how to get that from the data. Okay, let's bring up Excel. Here we go. Zip this over right here. Bring this down. Some of you may already know how to do this, but so just let me try to do this. Here we go. Control C, come over here, Control V, and then Control C, and then transpose, so make it a vector, Control C, and then make it numbers. Sometimes when you go Control C and Control V, sometimes the first number is a text. Then all of a sudden your numbers are off because it doesn't see that as a number, it sees it as a text. And so you got to be careful with Excel when you start cutting and pasting. What I just did, you copy it, transpose it, copy it, and then copy it, and then when you paste it again, you paste it with this value, just the values. So it takes away any formatting. Okay, I want the mean, the variance, oh yeah, and then alpha, or let's say the stock out level. Let's justify this, and let's make this I like Arial. The stock out level, let's see, what was it up here? 10%. So this is 0.1. Okay, so let's enlarge this to make sure everyone can see what I'm doing. Okay, does everyone see that? Okay, there we go. Okay, first of all, we want the mean. I want the variance and also the standard deviation. Okay. Oh, also, let's see here. Use the sample variance. You can have a sample variance population for two types of variances. We'll do sample variance. I'll tell you what kind to use. Sample variance. Bring this back over here. Let's full screen this. Here we go. I'm not gonna. I'll go ahead and calculate this. Then you can. First, you do equal, average, and it asks for the numbers. Now, when you say equal, I think I did this. Have I done? I haven't done this. I haven't done this in this course yet. When you say equal, and you type something, and it recognizes it, it's a function. See, this is a function. It's asking for numbers. You can type these numbers in individually, separated by commas, or I can left click, hold down, and drag, for those of you who never done this, and notice, and then in parentheses, and notice C6, column C, row 6 is the first number in this vector. Column C, row 15 is the last, but this colon means it's everything in between there. And so it's an array. So it's all those numbers together. When I press return, the mean is 450. See if you can do that now. The variance, now remember it's sample variance, equals variance dot S. S estimates the variance of a sample. Okay, open parenthesis, the same thing, left click, drag, in parenthesis, and then boom, there it is, 1320. Now the standard deviation, same thing, STDEV dot sample standard deviation, same thing, down like this. But if you remember, the standard deviation is the same as equal SQRT is a function square root. It's the same as the square root of the variance. Okay, and I say F, column F, row 7 is my variance. So that should be the very same number. Bing, 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 bing. So it just does the square root for you. Okay. Well, you need those. Oh, you need these. You need the z value. Okay. Remember last time the takeaway. You have your bell curve, and And the alpha stockout level is the tail of the distribution. But let's bring this up here. Okay. And then the z value, z value, okay, is, let's go ahead and justify all these. The z value, when you go equal normal, m, norm dot s dot distribution. Since it's a distribution, I'm sorry, if it's a distribution, go ahead and do this. If it's a distribution, it's asking for a z value, because this is the standard normal, the z value. So given a z value, it gives a probability. But I have a probability, I want the z value. So it's not the distribution, it's the inverse of that distribution. Now it's asking for a probability. Now that probability is the cumulative probability. That's the only thing that they define here. But the stockout level is the tail of the distribution, which is 1 minus the cumulative. So it's 1 minus the stockout level. That's going to be the cumulative if the stockout level is 10% or it's 90%. And so notice 1.28, and there's more than that. You can bring this down like this. It's a big number, all these significant. I think there's like 15 significant figures. A lot of people just say 1.282, just to be simple. But in the calculations for what we do, use Excel and use all the significant figures. That way there's no round off tolerance stack up of the errors if you look at error analysis. So use all the significant figures you have in Excel, because that's what I do. Okay. And then once you have your mean, standard deviation, and z, those three numbers, bring this down, bring this out of the way over here. Now you can go through and calculate the reorder point, the Q, the base stock level, the safety stock, and just plug and crank. You get all the numbers. Okay? And then down here on the part B, the same thing, they talk about it, but what I do here, I say, oh, well, what about the relationship between, and some of them, like it says, a continuous review system requires a form of continuous monitoring of the inventory levels / inventory position, such as digital monitoring. Okay, let's bring back the lecture. And notice, let's come back down to stochastic. Let me show you what I'm talking about here. Okay, here's the tail, and Excel only gives you the cumulative, this probability down here, but alpha is this, so 1 minus alpha is going to be the value that gives you your variant. Let's come down to so here's when I talk about stochastic demand. Okay, notice down here I talk about when it's used, how it's used, continuous review, computerized monitoring, for example, low mean. So I talk about usually when it's indicated, what the characteristics are, different types of things that actually use this, and also relationships. Relationships when it's used, and the usually situational. So that's what I'm doing down here. See? And that's just as important as knowing what the values are and knowing the relationship in here. Okay? And I do that for a lot of these. Okay? Okay, let's go on. Let's see. Okay, this one. This is a single period. Okay, distributors is re-examining one of their key inventory items because of historically inconsistent sporadic demand. Due to increasing short costs, boom, it's 704, a stochastic single period AOQ is being considered. In other words, they don't want to be short. Okay, and they're going to have in other words, when the short cost starts increasing, what happens is they're going to, it changes your stockout level. I think I say that in the homework too. Okay, because the stockout level, remember, is the let me pull this down here. Where's it at? There it is. Okay, is a combination of the short and long cost. Okay. That is, when long cost gets bigger, then the stockout level changes. Okay. For the same long cost, when the short cost gets bigger, alpha then becomes smaller. If alpha is smaller, then the service level becomes bigger. You want more. Inventory, so the lot size increases. I ask about all that. Okay. Anyway, the question is, before you can work this, let's bring this down. Boom. Let's bring this one down. Here's single period. Notice what I'm doing here. And again, this is fairly practical. At least I think it is. Here we go. I gotta see what I'm doing here. There we go. Okay. You have short cost, long cost, but what the short cost, long cost will create your alpha, and alpha will create your z, but you need the mean and variance. Okay, watch what I say here, and this is common. This does happen a lot, especially with government data. They're not going to give you the data. They give you histograms. They give you frequency diagrams. Due to increasing short costs, a stochastic single period EOQ is being considered. Data from the past orders were requested and received in the histogram given below, which is assumed to be normally distributed. Well, it's easy assumption. It's pretty darn symmetric, okay? That is a bell curve, okay? So that's what it's assumed. So the question is, when you have this histogram, okay, what's the mean and variance? Well, the mean is somewhere around 700, but what is it? Good question. Okay. Well, let's do it. Let me show you how to calculate a mean and variance from a histogram. I didn't really do this in the lecture, which is fine. I'll do it here. So you're going to have something called x, which is the midpoint. Let me just say midpoint of an interval. Well, that's the 500, 600, 500, 600, 700, 800, and 900, okay? Then you have your frequency. Whoops. Then you have your frequency. Well, that's given here, 25, and then 55, and 95, 60, and 15, okay? But then, that's all the information you have for here. So then, let's bring this up here. Let's make this big. There we go. So then, let's sum this, auto sum here, to 50. So then, let's create probabilities out of this. Well, that's simply going to be the frequency divided by the total. That'll give you a probability. But that B, see column B, row 25, I want that to be fixed. So F4, we'll put dollar signs in front of the column and row, and it'll fix it. So then when you go down here, see there's your, the sum is 1. Probability. Now, notice what I do. I'm going to say x times p equals x times p. Copy that down. Zippo. And then sum it again. Zippo. So that right there, let me make sure I did this right. I did. I just want to make sure the numbers are right. Anyway, that's the mean. That right there is the mean. That's the mu, x times p. Okay. Let me find it here. I want to make sure. Here we go. What number is this? 5? There we go. What did I get? Yeah, okay, 694. But then you need the standard deviation, okay? So this is x times p, and so you do the expectation of x squared, which is like the second norm. This is like a first norm, first moment. This is like a second norm, but it's a second moment, but it's not a moment around the mean. It's just a moment. It's just a second order expectation. The same thing equals x times p. See, copy that down. Okay, and then sum. Okay, now this is the mean, and this is not the mean. Not the mean, not the mean, not the mama. But what you do is you take this minus the mean squared. That's the variance. Okay. Okay, and actually it's a population variance, but that's all we're doing here. Now to get the standard deviation, let me just say SD, standard deviation, square root of the variance. And there you go. And those are the numbers you need to work the problem. Now you have that, well, almost. Almost. The next thing is the short and long costs. Okay. Let's see. The short cost is 704 and the long cost is 96. Let's do it right down here. C short, C long. The short cost is 704. Long cost is, what did I say? 96. Okay. So then alpha is going to equal, and this is given in the lecture somewhere. Got so many things open here. Let's see here. Where's my lecture? Here it is. That's my homework. Where's the lecture? There it is. Oh, I didn't. Oh well. It's the short cost. Let's see here. Okay. So so when the short cost increases, alpha decreases because, let me do it this way. It's going to equal the long cost divided by long cost plus the short cost. Okay, and so that's going to equal, now I'm going to equal, and this is going to be a calculation, long, what's long, 96? Yep, divided by 96 plus 704. And there's alpha, 12%. 12%, so those costs will identify a 12% stockout level, so an 88% service level. Okay, and then the rest of it, you just, down here, you just calculate. Get your Z, we've already talked about how to get Z. You're given mean, you're given the standard deviation, and then boom, which one of those numbers is right. So that's how you set it up. Now this down here, the stockout levels and service levels, I go back and forth between the two, and one's a definition, the other's relationship. So this is really talking a lot about this alpha here, because remember, this alpha is the stockout level for a problem, and 1 minus that's the service level. So that's what I'm talking about here. Okay. So let's go on. Risk pooling. Okay, now this one, a distributor has satisfied 3 wholesaler warehouses, 3 of them downstream, by managing 3 different inventories at 3 different locations. And so 1 for each wholesaler to keep the same service level for each wholesaler. Same service level. So you have the same service level. The distributor orders from the manufacturer every 2 weeks for each inventory at each location and receives the order 1 week after the order is placed. The distributor is considered placing only one order every 2 weeks, large enough to satisfy all 3 wholesalers from one inventory at one location. Now, what does that say? You got to read this very carefully. Let's do the setup. This is very common. Okay, you're looking at this, and you're saying a distributor up here satisfies 3 wholesaler warehouses by managing 3 different inventories at 3 different locations. So you have 3 different channels, one for each wholesaler, and they have the same service level. They keep the same service level for each wholesaler. So the service levels are the same. The distributor orders from the manufacturer every 2 weeks for each inventory at each location and receives the order 1 week after the order. So the lead time is 1 week. The inventory period is 2 weeks, right? They order every 2 weeks, that's T, that's the inventory period, and receive the order 1 week after the order is placed, that's the lead time. So you have the lead time, you have the inventory period, and it's the same for each wholesaler, each one of those inventories. Now, this distributor upstream is saying this is considering placing only one order every 2 weeks, large enough to satisfy all 3 wholesalers from one inventory location. There's 2 things going on here. First of all, large enough to satisfy all 3 wholesalers from one inventory location. Okay, from one inventory location. I may be overemphasizing this, but that's okay. So stick with me here. From one inventory location. So that's risk pooling, inventory risk pooling, right? You're taking 3, consolidate it into one central distributor up here to satisfy the 3 warehouses. Okay? That simple phrase there is implying inventory risk pooling to lower the costs. Right? Next, let's back up. What's the first part of that sentence? The distributor is considering placing only one order every 2 weeks. Bingo. If they place one order every 2 weeks, that's a very consistent order every 2 weeks. So that's a periodic review system. They're not looking at the inventory, they're every 2 weeks, they're looking at the time. So if it's stochastic, and it is, and if it's risk pooling and every 2 weeks, what do? It's the base stock level approach. So notice in this description, if you know what you're looking at, then you're saying, okay, well, presently you have 3 different demand streams from 3 different warehouses and 3 different inventories. If you consolidate, you're going to have risk pooling and lower the cost, be more efficient, and you do it with a base stock level. Okay? So there's all that terminology in that simple, 3 sentence, 4 sentence. To analyze a change, weekly demand for each wholesaler was collected over so there it is. Okay, there's the data. Okay, since the pattern of the weekly demand data over the last few years has been consistently bell-shaped, a normal distribution is assumed. To determine the feasibility of combining inventories, the correlation matrix for the 3 wholesalers was obtained. And boom, there it is. Okay, so you look at this and say, okay, so what? Okay, this is a big deal because this determines the feasibility of combining inventories. Should we do it? Well, let's come back to my lecture. Let's come back up to risk pooling. Echelon. Here's my risk pooling. This is on page 10. Okay, and notice this sentence down here: the lower the correlation between demand channels, the greater the cost savings, or the greater the efficiency. In other words, down here, let's full screen this. Down here at the bottom, I have an appendix down here at the bottom. Let's see, Appendix B on page 17 down here. And looking at Appendix B, I derive it here, but what I do, I give an example. So here's an actual demand stream. Here's an actual demand stream, and there's the mean, there's a variance, standard deviation, and the correlation is 0.5 between these two, the correlation coefficient. If you sum these up and compare that with the sum, okay, so this is a sum of the mean of the statistics. This is an aggregate of the data. Aggregating data is not the same as summing statistics. Two different things. When you aggregate data, you don't have the same information. It's different information. But notice what happens. The means doesn't change. The variance will always go up if the correlation is not 1. When the correlation moves away from 1, the variance always goes up. The standard deviation always goes down. Why? Well, I derive it up here. You can go through the derivation if you're interested. So, the idea here is this difference here from 14.2 to 12.7, that's how much decrease, a decrease in cost and an increase in efficiency this is giving you. So what I did here, I had a number of different correlations, okay, from negative correlated to positive correlated, because correlation goes from -1 to +1. So -1 all the way to +1 correlation. And here's how much decrease the standard deviation is. So notice when it's close to -1, there's from the sum to the aggregate, the decrease is significant. But when that correlation approaches 1, that difference starts to decrease. It decreases. And for a perfectly, if these two streams are identical, then these two numbers will be identical. Interesting. But if these two streams are a little bit different, then this will be a little bit smaller than that. If they're a lot different, this will be a lot smaller than that. So the more uncorrelated they are, then the more negatively correlated they are, the greater the difference of the standard deviations, and that translates right into your safety stock and efficiency and cost. Okay, and then let's come back up. So, well, let's go back here. What I'm doing then, I say, to determine the fees, if the unit carrying cost is $12 for each item over a week, then what is the total annual carrying cost savings by using 1 inventory instead of 3 inventories at a 90% level service level? Note, use sample standard deviation again. In other words, what I want you to do is pretty much go through this, and then once you have your mean standard deviation for this over here, well, for this and this and this, calculate the cost savings, the total carrying cost, and then see what the differences are. Okay. So, therefore, we're coming back up here to the base stock level. Where's my base stock level? There it is. So essentially, well, first of all, you're doing for the 3 individual ones. I think both of them. Let me see what I say here. I don't remember. Yeah, the distributor orders from the manufacturer every 2 weeks. So both are you have the base stock level. That's safety stock. Here you have the base stock level, which is periodic, for the 3 inventories, and then for the aggregate, and then then you add them up and see what the differences are. A lot of work. Not really. It's in Excel. By the time it takes me to explain this, you probably could have had it done. Okay, because I just keep talking about it. Okay, but then down here I have these relationships here. Then that's exactly what I'm talking about on part B. On part B down here. That's what I'm referring to down here. Okay. So therefore, okay. Before I get to Echelon Inventory, this might be another really good time to mention that come back to the website under Supply Chain Management. Down here at the bottom, here we go, Inventory. Right here, statistical safety stock, single period, and then base stock level. This is periodic review. These videos go through this in detail. Okay. Not only does it go through the detail, probably more detail than you really care about. For example, this first one here, I derive a lot of the equations. That probably is not necessary, but you can skip over that if you want. But it's there if you want to look at it too. And the reason I do that here in single period is because in textbooks they say it can be shown, but then I try to find it somewhere. I couldn't find it. I looked in a bunch of books and I couldn't find it. So I went back and derived it. Say, here's how it's done. So you can see how it's done. Anyway, if you want to. But anyway, these 3 videos will talk about those techniques. Okay. Echelon Inventory. So this one, I have, if you bring back the lecture, notes, risk pooling, Echelon Inventory. Notice I have this little this table down here, and essentially all I'm asking you is just take out these numbers from this table and then put in these numbers from this table, okay, and essentially calculate the these are the inventory policies, each one done individually, and then go through the echelon table, the echelon procedure, and determine the revised inventory policy. Then down here, see which one of these, is it A, B, C, or D, or none of the above. And I think it is one of them. I can't remember which one it is. Okay. So therefore it's just going through this technique right here. Okay. How are we doing here? And this is the B part. Okay. ABC inventory classification. This is probably one of the more practical multiple item analysis techniques that is in supply chain. And that's why I have it in here, because it's very popular, very common. Almost every textbook says ABC classification. Anyway, I mentioned it before. I kind of want to do it again. Okay, and that is an ABC inventory classification of 20 item inventory resulted in, I say 20 items just to keep it small to see how things work. Inventories, this is multiple items. So some inventories have, and these are different SKUs. Some are like, I don't know, 1,000, 2,000, 10,000 SKU items. When I was consulting, I think I mentioned this. This one company I had in Colorado had over 200,000 SKU items, and they said we need help on how to manage this. So we did ABC classification. It worked quite well. Okay, it's a way to organize your effort so people know what to do. Okay, here we go. So let's do the quantitative one first. Okay, then the qualitative really feeds off of it, and also you can look at the lecture. Lecture on Monday really covers a lot of this. Well, notice what I'm doing here. I'm saying, okay, resulted in a classification of 4511. Usage is given there. Assume an ordering cost and carrying cost. So let's pull these into Canvas again. Pull this down here. For A, B, and C, let's do A and B and C. Okay. And let's do the usage. I'll call it M. Whoops. M. This is the usage. This is 349852. This is 65156 and 25785. Okay. And then N is the actual classification. Now, what I mean by classification, 4, 5, 11. So this is 4, 5, 11. What I mean by classification, let's go back to the lecture. Here we go. Lecture. Up here, down here. Stochastic. Here we go. So, and this is on page 13 in these lecture notes. So here the idea, I say, well, you have your skews, you rank order them, do the cumulative percentage, and identify your A. And so once you do your classification, you classify 2 items as your A class. I classified 3 items as my B class. I classified 5 items as my C class. So my classification is 2, 3, and 5. So that's what I mean by classification. Out of 20 item inventory, my classification is 4, 5, and 11. 4 in my A class, 4 items in my A class, 5 items in my B class, 11 in my C class. Okay, and so there they are. Now up here, let's bring this up here, and my ordering and carrying cost. Let me put them over here. My ordering cost, whoops, the other way, is 135. Did it again. My carrying cost is $4 per item per year. And so remember, C sub O over C sub C. I'll just go ahead and do this. I asked for this. I'll just go ahead and do it. C sub O divided by C sub C. This is EPP. So now we know EPP is 33.75. I think I do ask for this down here. Yeah, the EPP is, which represents, so statement 2 is true. There you go. So that one's true. So 0 is not the answer. Okay. Anyway, let's go back. Let's go on. So now what I'm saying here is that for the inventory policy 22.14.1, this is the classification. I call this my inventory policy. Well, my inventory policy, though, scoot this over. Okay. My inventory policy, call this F, is 22, 14, and 11. That's the frequency of every one of those items in that class. All 5 of those items are going to be ordered 14 times in a year in my B class. And this is 11 times for those 11 items. Okay, so I call this my policy. And let's center everything. Okay. Then I start talking about, and I say, okay, is approximately 40. Oh, let's see here. What am I asking? Oh, notice the inventory policy 22, inventory policy 22, 14, 11, inventory policy 2014, 11. So statement 1, 2, and 4 talks about this inventory policy. Statement 3 talks about the optimal inventory policy compared, which is 3, 10, and 4. They're saying the optimal. So I'm saying this is the optimal. Is that true or not? Yes or no? Okay, so the idea here, let's do the 22, 11, and 4 first. I say, which are the annual frequencies? The total annual order frequency is that. The EPP is approximately 41 for the entire inventory. So you'll have EP. Okay, here's what I mean by that. Well, I'll do that. Well, let's do it now. Here's what I mean by that. Okay, we can have the total orders. In other words, that's going to be well, NF. That's the orders. In other words, if every one of these items are going to be ordered 22 times, the total orders then is going to be 4 times 22. Okay, and then that's how many orders in each one of those. And then down here you sum this. So what I'm saying here is this sum then, this sum is oh, the order frequency is this. Oh, the sum. I'm not there yet. Sorry. Gotta remember what the question is. And then you have your average inventory. Okay. Well, there, if you take the usage and divide by the actual frequency, that's going to be your lot size Q. Q over 2 is the average inventory. So this is 2 times F. And we did this last time. So this is going to equal M divided by F divided by 2. And there we go. And bring this down. Ka-chinga, ka-chinga. And then you sum that up. Okay. I don't know if I asked about that. Then we have the EPP. But this EPP is the observed EPP, which is equal to, which is equal to the average inventory divided by the total number of orders. Okay. And so all I'm saying here is the average here of these three, I'm saying the average is 41. Oh, no, I'm not. Then I say, darn. Let me go ahead and sum this. So that's one answer. There's another one. Then I'm saying if I take this divided by that, is that going to be 41? Or approximately 41. That's what that question is saying for the entire inventory. So you take the entire inventory. In other words, now the reason I'm doing this, okay, let's talk about practicality. We know the optimal is 33.75, but notice the only one that's closest to that is the B. This is way too low, that's way too high. Okay. In other words, it's C sub O over C sub C, average every. This inventory is way too much, and these are too low. You need to change these things around because that's way too high. This is too low. Okay. So the average here of the entire inventory is going to deviate from 33.75, but that doesn't mean, even if it was 33.75, then all of these need to be balanced. And when they're all the same, that just means you have a balanced inventory. That's what that means. Okay, and then well, 279, that one's true. 41, you got to do that one. The optimal, haven't done that yet. Oh, and then the minimum cost. Okay, so essentially, is that optimal? And then what's the cost on this one? Well, we're already here on this one to solve it. Okay, we bring down these unit costs. The ordering cost right here, orders, is 135. and this one is 4. You multiply these, you got your total cost right there. Okay, and then you add them up to get the inventory cost. That's what this is talking about right here. Now, as far as the optimal is concerned, if you go back to the lecture, if you recall, I gave this the order frequency, which to minimize your cost, the optimal inventory policy is that equation right there. So let's take this equation. Control C. Let's go back to here, and let's put this down. Let's put this up here somewhere. Let's see. Let's move all this up and put it right here. Mess around too much. Do it again. Control C, Control V. There we go. Now let's left justify. Okay. So now notice there's the equation. So what you're going to do down here, call it F star, because this is optimal for categories A, B, and C. This is going to equal the usage here, or the square root of the usage M divided by 2 times the classification N, which is 4, times EPP, which is going to be 33.75, because that's the optimal. That's the optimal EPP. That's what you want. Bing, bing. Press return, and you got your answer. You do the same thing for the B and the C item, and you put this in there and get your costs. That's pretty much how you do it. I'll let you do that. Oop, took away the wrong one. There we go. Oh, and then these talk about the different types of uh-oh, did I make a mistake? Let's see. Do you divide F by 2 or multiply it by 2? Oh, this is a while ago. Okay, could you, I have a delay here. See, are we supposed to multiply by 2? Are you talking about ABC classification? Could you ask this again? Which one are you talking about? I want to make sure I didn't mess up. Are you talking about the frequency? This right here? The 2F? Oh, I did. See the 2? I did multiply it by 2. Yeah, for average inventory. See, I did multiply it by 2. Up here. So this divided by this divided by 2. It's question 8. Oh, let's go look and see. Okay, let's see here. F39. Uh-oh. Thanks, guys. Let's go look at this. F39. F39. I don't think so. I don't think so. That looks right. In other words, I think what you're saying is equals the M divided by 2 times F, right? So I'm dividing by 2 and I'm dividing by D39. See, that's the same number, because that's the same as this divided by F divided by 2, because I'm still dividing by 2. It's the same thing. Is that what you guys mean, or am I missing something else? Oh, F38. Oh, that's the wrong, I don't think so. Let's back up here. Let's bring this in and see. Nope, right there, average M over 2F. I'm pretty sure that's right. M over 2F, M over 2F, M over 2F. Is that good? You guys agree, or is there something else I'm missing? Are we all in agreement? Oh, so you got it then. So is everything okay? Is that a thumbs up? Awesome, awesome, awesome. Good. Now there's actually, I'm going to come back to this in a minute. Great, great. We're going to come back to this in a minute because this is only one type of analysis. There's a multiple number of analyses. When I was thinking about yeah, Sandeep. Okay, Sandeep. That's true. Whoops. But only, your equation is true only if you had the parentheses, if you had m divided by f over 2. Then it would be what you're talking about, but that's not what it says. I'm gonna revisit this this right here again because there's more analyses we can do with this. Some really good stuff that I think I'll do in a next week or so before we get out of here. Because before we get out of here, let me show you what I mean by that. Let's bring the syllabus back up. Like in logistics, and then relationship, whoops, and then information. So I probably have, I'm really looking at shifting this back a week, and also spreading this out over 2 weeks instead of 1 week, so you have more time to deal with this, because there are more analyses we can do with the I got so many things. Here we go. More of this ABC classification. There's a lot more that can be done. Okay, question 9 here. Consider each inventory policy approaches. Consider each of the inventory policy approaches briefly described below. Continuous review, periodic, single, period, ABC classification, echelon. Upload 1-page report in a PDF file. In your report, identify and describe a supply chain and present how one of these approaches would be effectively used. At the top of your report, entitle an inventory policy for a supply chain in your name. Actually, inventory policy for a commodity supply chain in your name. So the idea here, well, I say describe a supply chain, I mean a commodity supply chain. So make sure it's commodity. Okay. Because or not, doesn't have to be. Well, actually we have commodity supply chains. We have analytical supply chain, we have service supply chains, international supply. Actually, if you're an international, maybe make it an international supply chain. If you're doing, if you're energy, whatever, that's a commodity, or retail, or whatever. But just make it a supply chain. So you describe a supply chain, and you picked one of these, and say, this is an inventory technique that can be used for this particular supply chain. Because some of these are good for some supply chains, and they're not that good for others. Okay, so it's not so much how accurate you are, but I just want you to go through the thought process of thinking about how these inventory techniques would apply to a very specific supply chain. Now, if some of you in the past years, past semesters, people who say, we really don't know anything about supply chains, can you help us? I go, yeah, sure. What I did here in the introduction is over here at the end, I talk about There we go. I talk about talk about metals, talk about agriculture, cotton, talk about metals, iron ore. I talk about energy, electricity. So right there's three. I mean, all kinds. There's retail supply chains. So here's agriculture, metals, and energy. There's three. So that's the idea, okay? And so that's kind of what I was talking about when I was saying commodity, because the commodities would be more upstream, but eventually they're going to come all the way downstream. A product supply chain, international supply chain. You know, where would the inventory be used? Inventory policy would be used. Is it periodic? Is it continuous? Is it stochastic? Is it a single period? I know. We had a speaker from New Zealand about dairy, and their inventory policies are pretty much single period, because the lead times are so long. They're talking about 3 to 5 months. But anyway, just it's not so much how accurate you are, but just think about how this would work. Now, some of you may be working in supply chains, and that'd be perfectly fine. Picking something you know. In other words, if you don't know anything, just pick something that sounds good and try it. The point is, we're learning here. We don't have to do everything right now, but we have to do it. And how good and bad we are, we're going to get better. We just have to do it. The best way to do this stuff is to do it. And the more you do it, the better you get at it. Okay. And so when we're done here, after 16 weeks, we'll be fine. We'll be much better than we are now. So just sort of give it a shot. That's what I mean by that. By this last question here. Okay. So you have 5 of them to pick from. Okay, and then let's come back to the syllabus. Be watching for announcements on Canvas, because I probably will change this due date. I'm pretty sure I want to change this due date to maybe next September 6th, maybe. Haven't quite decided. I have to look and see if that's going to work. So we'll have 2 done that day. I might even do it even later. I don't know. I have to look and see what I'm going to be doing. I probably will be modifying these homeworks. That they're made up, but I might modify them before I post them to accommodate the first homework. Okay. Anyway, so be watching for announcements. In the meantime, get into this. There's a lot of material here, but it's all good material. It's all very practical, especially the takeaways at the bottom. So get used to these takeaways and get used to get a feel for how this stuff is used, because it's very, very practical. Wherever you go, whatever you do in business, you're going to be around operations and supply chains. Okay, it's going to be there everywhere and somewhere. Okay, so that's all I have for today. And for those of you, no one really said they wanted a Zoom, but it's easy enough. It's easy enough for me to just open the Zoom. If anyone wants to ask me a quick question or anything, I'm fine with that before everyone leaves. In other words, down here, I'm going to open this Zoom session. These are all the same Zooms. I'll open this Zoom, and if anyone wants to ask a quick question or get clarification on something, or we can have a conversation. So that's all. So we're going to open this here, and then I'll answer questions, then I'll be done. So that's all I have for tonight. I hope this helps. I hope this helps because I want people to really learn this, because initially there's a lot of information and it's technical. But the takeaway, I think the technical aspects, the quantitative, is necessary to understand the qualitative. So they go hand in hand. So that's all I have. We'll go through Zoom and be watching for announcements. And so between now and the next time I see you, take care. Be very careful out there. Don't take anything for granted. Be extra safe. Stay healthy, because these next 16 weeks, I want you to learn as much as you can. And you can't learn, you can't think if you're not healthy. So stay healthy and take care.